Hello, my name's John Padgett. I will be your Weather Merit Badge counselor for this virtual Merit Badge fair. Couple of things about myself. I was in Scouts, got an Eagle Scout. My two favorite merit badges growing up were taking cycling merit badge. I did a lot of bike racing, and the other favorite merit badge was small boat sailing merit badge. All those activities are very weather dependent. If I had the opportunity, I grew up in Texas, I probably would have knocked out the snow sports merit badge too. That's one of those other favorite merit badges or activities that I do now that I live in the Pacific Northwest. But all those activities are super weather dependent. So that's turned me into a little bit of a weather nerd here. I'm going to go through a couple of details. There's this lecture's going to last an hour or so, but we'll run through the requirements, sort of how to connect with me, and I'll give you some tips and resources for different ideas for knocking out your merit badge requirements and how you can loop back around with me to complete those requirements. So first of all, you're going to want to make sure that one of your unit leaders connects with me on a scout book, and so or connects you with me on scout book. So one of the things, there is a scout book merit badge counselor guide, and it sort of goes through some details of on how I connect with you here, so that might be worth reading there. And then just like any other merit badge, you might have taken one where you use the blue card. We can do that too if the technology gets a little bit overwhelming for anyone, and we can email that back and forth with and put some signatures on it and everything. I can certainly do that. But there's some unit leader instructions. The biggest thing they'll need to do is find me in Scout Book as a merit badge counselor, and then get um, you connected with me as your counselor. So um, here's what I look like in a merit badge counselor. So I'm John Padgett. I'm the guy on the bow of the sailboat there. One little trick for finding me as a merit badge counselor is I do not live in North Seattle. I live in South Seattle. So my zip code is a 98118. So there's probably a whole bunch of weather merit badge counselors that are a little bit closer to you. But thanks to COVID and the virtual world, we can connect certainly via the phone, the um, also certainly um, via email. There's my phone numbers right there. The first phone number, the 902-2355, is my office phone. I'm mostly working from home during COVID right now, so probably be easiest to reach me at the 206-226-2452, my mobile phone number. Just a reminder that when you reach out to me, if it's on video conference or if it's on the phone, make sure that there's another parent or guardian there with you in the room there. So we're meeting the 2 deep leadership requirements of the Boy Scouts. If you reach out to me on email, make sure that you do CC another adult. So we're all following the youth protection guidelines of the Boy Scouts of America. So what we're going to do to get this going here is we're going to watch a cool video I found. I'm way into sailing, bit of a nerd in that. And it's about a boat that recently broke the transatlantic crossing record. And there's quite a few weather events that they used to their advantage, and also potentially created some dangerous situations for them. So later on, we'll loop that back around to the requirements, but it's good to watch this because we'll talk about some of these phenomenon in the requirements here too. So let's get that rolling here for you. And So I'm going to pause it right there. They're talking about weather systems. So the older, slower boats were able to keep up with one weather system for a while, but eventually it would overcome them. And they would have to catch up with another weather system. So specifically, we'll talk about high pressure systems and low pressure systems. They're looking for low pressure systems that are crossing the Atlantic at a, 40, 50 degrees of what we call the westerlies. And we'll talk about that a little bit more. But you see on the screen there, he's using some weather modeling software and looking at a low pressure system and how that's crossing the Atlantic there. So we'll talk about that a little bit more. But when he says a weather system, we're talking about a low pressure system. So I'll pause it there for a second. And low pressure systems have frontal systems attached to them. So they're, in this case, Stan Honey is talking about a cold front and trying to stay ahead of that and stay out of the lightning that occurs when the cold, dry air wedges underneath the warm, moist air. And I think we'll see later on here in the video what happens there, but that can be a sort of dangerous weather event with lightning and thunderstorms there. So sort of interesting that they bring that up in their briefing before they set off. So I'll pause there. I guess that the thunderstorms weren't necessarily unexpected there, and one of the sailors made mention that they were going to put themselves in harm's way to try and break a record. So we'll talk about safety elements and one of the requirements that you'll want to look at before you go on an outing, like something like a snowshoe hike or something like that. And certainly there, the weather phenomenon we'll be looking at would be a little bit different than sailing here, but certainly thunderstorms wouldn't be good for hiking either, and we get those here in the Pacific Northwest, although not nearly as common as the Midwest or the Northeast of the Americas here. I'll pause there for a second. One of your requirements would be to give a weather briefing before an outing, and some of the gear that you might want to bring should be part of that weather briefing there. So you saw the guy complaining, wish he had new boots. So the low clouds and the drizzle there probably means that they have been overtaken by a warm front, but are out in front of the cold front in this low pressure system that we'll talk about here in a little bit. But we'll see how low the clouds get here in a sec. It's an interesting phenomenon he talked about there with the ice in the ocean. It's going to lower the dew point and improve the visibility just locally in that area. So interesting, another phenomenon of the weather. Interesting. He talked about there, we'll talk about high pressure systems. So a ridge is a sort of oblong shaped high pressure system. So we'll talk about that here in a little bit when we go through the requirements. So, but the low that they were in was powerful enough to displace the high pressure system. righty. And here we are. Okay. All right, back at it here. So jot down my contact information there from that slide there, but we're gonna take a couple minutes. We'll go through the requirements. I'll give you some resources to knock those out. A couple of things you'll probably want to get are a Weather Merit Badge book. There's a lot of all the resources in here for anything that you're interested in. Something to do, a potential career, or something you need to knock out. Get the Merit Badge book. They're like less than $5. You can pick one up from the library as well too. But it's got all the information you need by the authoritative resources to make that happen. All right. Define meteorology. There's a definition in your book. I explain what weather is and what climate is. That's in your book. So go through and we went into detail how it affects sailors, but it also affects people with their careers, our food supply. People are involved in aviation, moving people around the country and the world, our outdoor construction industry. So give a definition of why this is important to all of these groups here to keep an eye on the weather. A good way to do that, you can go to meritbadge.com and they have these nice little worksheets that you can fill in with your answers, and that's easy enough to email to me and we can just tick off that requirement there. But do a little research, put it in your own words here. 5 dangerous weather related conditions and some safety rules when you're out of doors. In your book, you'll find a difference between a weather watch and a warning, and then discuss those safety rules with your family there. So we saw certainly some thunderstorms, lightning, heavy breeze, icebergs, certainly in the film there, probably cold water, also weather related there. So a low visibility. Those are all weather related conditions that might have some safety rules for when you go out of doors. So think about also the things that you're doing with your troop there. Discuss that with your family and jot those down in your worksheet for me. All right. Okay, cool. We get to talk about high and low pressure systems in the atmosphere. Good weather, bad weather, draw a cross section of cold front and warm front. We'll talk about that here in the next couple of slides. How they move cold and warm air around the low pressure system. And then the type of clouds that are associated with different parts of the frontal system and where you're going to find the precipitation. So let's dive into that here. Let's talk about our atmosphere. As far as weather, we're talking about the troposphere, which is our surface weather, whether it's down here at sea level next to the Salish Sea, or we're getting up into the mountains, or then we're getting into the stratosphere, the upper levels, so, where jet airplanes fly, Mount Everest, as you see in the diagram there. All right. So let's talk about this. The wind that's going to move these weather systems around the globe wind is created by the unequal heating of the Earth's surface. So we're going to get more sunlight near the equator. Let's get the annotation tools here. So and the All right, cool. So we've got certainly the equator right here, and you've got the poles up here, and the southern pole down there, the South Pole. Um, so you get more sun around the equator, less around the poles. The Earth is moving around the sun every 365 days, and it's not diagrammed here, but the Earth is tilted on its axis, so we have seasonal movement of all this. So uh, anyway, so because the sun is mainly shining on the equator, we have a low pressure system that hangs out there, and then between that low pressure system, we have the horse latitudes in the subtropics, our typical Mediterranean climate. If you think about California, if you spun the globe around here, then you would have the Mediterranean countries that are, around 25, 30, 35 degrees north or south latitude. And the horse latitudes, there's not much wind there because you've got a high pressure system dominated. So we've got breeze in between there along the northeast trades in the tropics and the southeast trades in the tropics below there. So you get a higher latitude than the subtropics here, and we have westerly winds that are moving from west to east, around the 40, 50 degrees. And then we uh, get to the polar highs and the polar lows. So these are just opposite on different sides of the globe. Wind being generated by unequal heating of the earth. We got to remember that the earth spins around once a day every 24 hours, so we get some unequal heating there, creating wind too. So we'll talk about some uh, sea breezes and land breezes that we get either in the morning or the afternoon there too. uh, so we get a great sea breeze here when especially in the summertime, when the eastern Washington heats up to 100 degrees and sucks in the cool air, or the cooler air over the Pacific, because the water's, upper 40s, lower 50 degrees, and pulls that in through the Strait of Juan de Fuca. So in the summertime, you typically have gale force winds there in the summer. All right, let's clear all drawings. All right. And come on, slide. There we are. All right. Um, this is a synoptic chart that you're looking at here, and it's showing low pressure systems, high pressure systems here. You can see right over here, it is state of Washington. You can see where Puget Sound is. And remember that we're living in the westerly, so this line right here is 40 degrees north, sort of running across Oregon, and then 50 degrees north here, just north of the border of Canada. So right in that area, we have what are called the westerly winds that are driven by the polar high to the north, and then right between there and the horse latitudes, or the our Mediterranean climate off of California here, it's dominated by this high pressure system. So a little bit of a anatomy of this. We've got a low pressure system here. All these lines around here are lines of equal pressure, and we measure pressure, at least here in the United States, in inches of mercury or millibars. And on this chart, they're measured in millibars. So if you've taken hiking merit badge, you've looked at or orienteering merit badge, or any of the requirements sort of going through first class, you've probably looked at the topographic map. So think of this as a topographic map where Going to the high pressure systems, this is climbing up a hill, and then going toward a low pressure system, this is going down in a valley here. So, and this is barometric pressure, or the how much pressure is exerted from the atmosphere down to the surface here. So low pressure systems typically associated with stormy, rainy weather. They have frontal systems attached to them. High pressure systems like over here off the coast of California, typically associated with dry, um, uh, cooler, dense air. Um, Makes for a nice sunny 70-degree day, not a lot of wind. Here on the low pressure system, we've got a lot of wind coming at us. This low pressure system has several fronts attached to it. Right here, the this is a cold front with the blue diamonds facing the direction that the front is moving. Remember, these are moving from um, west to east. So moving from left to right across your screen here. Um, and the cold front is going to be uh, drier, cooler air behind the front, and it is wedging underneath and displacing warm, moist air. That's where you get the most friction. You get upward movement of warm, moist air, creating thunderstorms, lightning, and those kind of conditions. Here attached to the system here, we've got a warm front. That is where um, warm, moist air is displacing cooler, drier air. That's where we get low clouds, drizzly precipitation. And then where the cold front has caught up with the warm front, we have an occluded front. All right, let's move to the next slide here. So this is sort of the next day here. This is the forecast here for this pressure systems catching up with us, and you can see Puget Sound right here. We're about to have the warm front catch up with us, followed by the cold front. We've got a bit of breeze. It says gale force wind, so 35 knots. You see the wind arrows with the direction of the wind. If I and so this is showing 35 knots because there's 3 long feathers off of there and 1 short feather coming off of there. If I go back here, we can see some of these wind barbs. You can see that around a low pressure system in the northern hemisphere, the wind is going to go counterclockwise around the low pressure system. And when we look at the high pressure system, we can see the wind bars. The wind is going to be clockwise around there, and we've got a whole lot less wind. And then, especially in the middle of the high pressure system, we've got no wind at all. So imagine on a high pressure system, if we had a balloon here and we squeezed it down, it would spread out. And that represents the dense air descending from the atmosphere because it's got a lot of pressure on it, and it spreads out. So in the middle of the high pressure system, where's my mouse? There we go. You're not going to have a lot of wind, but adjacent to this low, you can see how close these isobars get to each other, and you get quite a bit more wind. All right, here we are. This is a chart that shows what the wind is doing in the upper levels of the atmosphere. If you watch the weather report, it's called the jet stream. So here we are in the westerlies, and you can see that as we go up into the atmosphere, the wind increases quite a bit, and it's going to drive it's going to move around these low pressure systems around the high that's in the Mediterranean there, and sort of bring these weather systems to us. So here in the Pacific Northwest, we're looking out in the Pacific for weather to come. We're not too worried about what's going on in New England and stuff. Like what hits us there, it's eventually going to go across the continent here and get to them. But we're interested in what's coming, not what's what's happened here. So we're looking out into the Pacific here. Here you see the wind barbs here. You've got 95 knots of wind right here. The pennant represents 50 knots of wind, each long feather 10 knots, and the short one 5 knots. So you got about 95 knots of wind. So up in the upper levels of the atmosphere, this is going to be, 10 to 15,000 feet up in the atmosphere here. So certainly if you're an airline pilot and you're flying from here to China or Japan or something like that, you're going to do your routing so you're not right into these headwinds. If you're coming back from there, by all means, take advantage of these winds and get there with a little less fuel and a bit faster. So that's the jet stream or the upper level winds that are steering these pressure systems around. They move a little bit slower at the surface, but those are moving those around. This diagram's in your book, so pick up the book there. And this is the cross section of a cold front. Remember, we saw that on the chart with the blue arrows in the direction that the front is moving. So here we got cold air over here, and it is pushing itself underneath the warm, moist air. And so that's where we get our cumulonimbus clouds, because it's pushing that warm, moist air up into the atmosphere, creating a lot of friction with the temperature differential. That's where we get our lightning and thunderstorms and a lot of severe rain there. And you got, before and after that, you got some low stratocumulus clouds. And but the worst of it's going to be right along the frontier. We can also have cumulonimbus clouds pop up just because of a hot day with some moist air too. So you'll see that in the Midwest quite a bit too, where it's not attached to a frontal system. So here's a warm front. Get the low stratus and nimbostratus clouds there. A lot of sort of consistent drizzly rain, and that's where the warm air has pushed its way over some colder air. All right, what causes wind? Well, hey, that's the unequal heating of the earth. When it rains, I think we've covered that, how lightning and hail are formed. So back into that cold front with the cumulostratus cloud, or you got a hot day with warm, moist air. You got a moisture building up into the atmosphere. You can get a thunderstorm there. So, so how lightning and hail formed, and we covered that in the video we watched there. So fill that out on your worksheet. Identify and describe clouds in the low, middle, and upper levels of the atmosphere. Relate these to specific types of weather. So you've got this nice diagram in your book there that talks about the different clouds you see in different parts of the atmosphere. So, and then we can relate those to different sections of that low pressure system and the fronts that are attached to that are moving from, at least where we live, from west to moving from west to east in the atmosphere. All right, these Latin words, cirrus, curl or tendril of hair, stratus, like a blanket, cumulus, a heap or pile, nimbus, rain. Those are the Latin formations of the words that we use to describe clouds. Draw a diagram of the water cycle. I mean, this is awesome. I would just, since you live here in Seattle, I'd pick the Cedar River watershed. Starting up in the mountains. The mountains also are going to push air in the atmosphere coming from west to east up against the mountains, create precipitation, thunderstorms there, especially on a hot day. We've got a nice picture once again, in your book of the of a water cycle here. So, yep, those are going to frontal systems are going to roll through. The mountains are going to create precipitation that's going to run off the surface into our rivers, eventually into the Salish Sea, out into the Pacific Ocean, where it all starts over again. So that's your water cycle. So draw a diagram of that on your worksheet, send that my way. With some explanations there, we can talk over it over the phone or on a video conference. Some human activities that can alter the environment and how to affect climate and people. Deforestation, adding carbon dioxide to the atmosphere, global warming. Those are all explained in your book there. So do that. Pick out some human activities that alter the environment and how they are affecting our climate and people. Okay. Describe the tilt of the Earth's atmosphere, or describe the tilt of the Earth. And we talked about this earlier. Its effect on climate, the regions near the equator, the poles, or some areas in between. Once again, there's a nice diagram in your book about how that changes as we go out through the 4 seasons throughout the year. It happens daily with temperature changes. Remember that unequal heating of the Earth creates wind, moves weather around the Earth. So anyway, there you go. You can, that's how the Earth's axis tilt creates those seasons, creates, good skiing in the wintertime, moves that high pressure system that's normally over California up our way. So we have that sort of Mediterranean type summer here. All right. Oh, cool. In your book, let's see if I can find it here. Oh, yeah. So, in your book, you've got how to make a wind vane, how to make an anemometer, or really cool, how to make a hydrometer for relative humidity. So make one of those gauges. Use it when you're keeping your weather log, and take a picture of it or a video of you using it. Sort of give you an idea how weather data is collected there. So the other part of this requirement is to keep a log for 30 days. Listen to the weather on the news, weather radio. Also write down what the forecast is for the next day. And then when you go back and fill in what it's actually doing that day, you can sort of get an idea for a whole 30-day cycle. We'll probably have a couple of low pressure systems. We'll have some be dominated by some high pressure systems. You can look and see which direction the wind is out of those days, how strong the wind is. Correlate that to the temperature and sort of record that barometric pressure either in millibars or inches of mercury, and you can see how the high pressure systems, low pressure systems, the attached fronts are affecting the weather. So anyway, there's some nice directions on how to make an anemometer. There is a start of a weather log in your book there too. That's what it looks like. So you'll have to make some arrangements. You may already know some people that are involved in weather forecasting, private meteorologists. We've got some that Larry Schick does the Grand Poobah of Powder skiers forecast. There's some sailors forecasts. There's some forecasters that help with agricultural weather. Um, so find someone to visit. You can visit them virtually, certainly, since we've got a pandemic going on here. And then gives you a couple of leading questions to ask those people what kind of weather is most dangerous or damaging to the community. And you might get a different answer depending on the type of forecaster that you're working with there. And then those people, especially in the media, they're responsible for determining or reaching you with weather warnings. And so that's another leading question for them is how they deliver those warnings to you for how severe weather, floods, we certainly have floods here in the Pacific Northwest, reach your home and your community. All right. Similar to the earlier talk on severe weather that you do with your family, with your unit, or maybe your local Cub Scout pack, if you're den chief or something like that, go over some rules for outdoor safety, especially if you can tie this into, current outing. We've got snowshoe hikes coming up and stuff like that. So it might be good to talk about avalanche danger and how we can mitigate and avoid that. So the kicker is here is you need to make an outline for your talk. 5 minutes and share it with me for approval before you give the talk. So make sure you check that off there. There's in the back of your book, there's a list of careers in meteorology. And so pick one that might interest you, and then we can have a discussion of what training and education are required for that position. So that's some more homework to do. Hey, that's the 11 requirements to knock out. So there's my contact information. This didn't wind up with my mobile number, which is best to reach me, but that's 206-226-2452. And like I said, we can get together over email, phone. We can set up a video chat here too. Just make sure that when you're connecting with me, there's either another adult in the room, or if you're reaching out in writing, that you're CCing another adult parent guardian there. So we're all meeting the youth protection guidelines of the Boy Scouts. Look forward to meeting you and working on Weather Merit Badge with you.